Howdy everyone, this is Ryan with 5050 Tech Area. Today I have a very interesting video that I want to, or at least a topic that I want to share with you guys, and it's all about circuits. Circuits are a big thing in buildings, homes, schools, and all that, because without circuits we wouldn't have electricity and lights and microwaves and all that fun stuff. So let's go on with circuits here. First off, there are three types of circuits that we need to know about. They are series, parallel, and combination. The first one, series, we'll quickly draw here. Series, homes don't really have series circuits because if we had series circuits, you would have to turn on the light to turn on the microwave to use that microwave. So, getting on with this, let's quickly draw a small series circuit. So, what we want to do is we want to start off with the battery. This is the drawing of a battery. I won't go into all the AP physics stuff. This is just for the regular stuff, so don't get mad at me if you say, oh, that's negative, that's the positive side. I'm just doing this just to share with those who want to learn basics of circuits. So this is a battery, diagram of a battery. We want to draw a small circuit here. This right here is what's called a resistor. What it does is, in a circuit, all these electrons, they're going at a high speed, and what the resistor does is it resists the electrons charging or moving around the circuit, so that if light bulbs or other stuff were connected to it, the fuse would not blow out and all that stuff. So, series circuit goes in just basically a circle here with resistors going all around it. Parallel, though, is what you would most likely see in homes, businesses, and all that stuff. So, in a parallel circuit, actually, before we go on, in a series circuit, if the power source happened to go out, everything would go out. So, like a Christmas tree lights. If one light, since that would kind of be considered a series circuit, if one light bulb goes out, all of the light bulbs go out. See what I mean? Since it's in a one huge loop here, anything that's along the line here would go out if one thing goes out. So that's why they pretty much kind of invented parallel circuits, which looks like this. We have our battery or power source. You would go draw like this, draw a resistor down here, go up, go back over to the power source. Now, there's something different about the parallel from the series. Is that we can draw a resistor right here, and let's draw a resistor right here. In a parallel circuit, you wouldn't have to turn on your light to turn on the oven, to turn on the microwave, to turn on the stove, which you would need to use the stove. In a parallel, let's say that this is the microwave. Actually, these are the lights, this is the microwave, and this is the stove. If you were to turn on this power source, it would go to the lights, to the microwave, and to the stove, like a series circuit would, but If the lights happen to go out in the kitchen, the microwaves would still be going and the stove would also be going. So, if one thing was taken out, both the other things would be working still. But in a series, if one thing happened to be out, everything would be out. See what I mean? See the difference between parallel and series? And now we go over to combination circuit. What is a combination circuit? It is a combination of a series and a parallel circuit. And this is how you would draw a combination circuit. Let me just write the word out here real quick. Combination. Alright, in a combination circuit, you would have to draw it out like you have the battery source, you would come over, you would kind of create like a rectangular sort of shape. Then you would draw a resistor up here, go over, go down, finish the box here, finish that, go up. This would be the parallel part of it, as you can see, because it kind of makes that box sort of thing. Then you would go down here. This would be the series part of it. Just to let you know, I haven't done nearly as much of combination circuits as I have been doing with series and parallel, so I'm not. If any of you who are watching this video know more about combination circuits and would like to leave a comment below, do what you can to kind of explain what combination circuits do. Like, if one goes out, would the other two stay, or would they go out? All that kind of stuff. Alright, so let's continuing on with our circuit stuff. We need to know some other quote-unquote stuff that we need to know to actually do some circuit problems. We need to know what kind of equations do we need to use? What kind of units are there in circuits? Well, when you're using circuits, some main equations, there are going to be two equations that you need to really know. And those equations are V equals I times R. So in this equation, V is the voltage, which is the power source in the circuit. That would be like a battery or a light bulb, that kind of stuff. The I is the current. That is how much kind of like with the light bulb, if there's not a lot of current going through it, it won't be as bright. But if there's a lot of current going through it, you get a bright light. And that comes from the voltage. And the R is the resistance. And that gives a circuit the opportunity to say, hey, there's too much, will you please tone down the voltage or current in the circuit. So if we didn't have resistors in circuits, like if it were a circuit for a series of light bulbs, like if we didn't have a resistor, those light bulbs would blow out. But since we have resistors, the light bulbs won't blow out. So, continuing on, we have our second equation, which is going to be, it's going to be P equals IV. P is the new part in the equation here, in which P is equal to the power. That means like how much power is in this circuit. So we need to also know what the like the variables or what they are. So for the voltage, you would be using volts, like 120 volts of a battery, 90 volts of a battery, that kind of stuff. And current is going to be amps, amperes, amps, kind of like it amplifies the power for certain things. Kind of like an amplifier for a guitar. If you plug the amplifier into the guitar, it amplifies that sound for the guitar. Resistance is going to be actually my bad. Yeah, no. I was right. They're gonna be ohms. That is, I don't really know how to explain what ohms are. So, we need to know what they look like. Like volts. The letter for volts, or whatever you want to call it, is V. Amps is A. Ohms is something different. It's not a letter like P or Q or I or A or V, that kind of stuff. It actually comes from the Greek letter omega, which looks like this. Those are the main variables, along with power, which I almost forgot. That's gonna be watts. You've learned from previous units what watts are. That's kind of what you actually need to actually get things to actually do things. So now we're gonna be doing some problems. Alright, so we're gonna do this one problem, and then I'm gonna create another video which will include the other two problems in this. So this first question asks us, draw a series circuit with a 95 volt battery consisting of two resistors, with one being at 5 ohms and the other being at 12 ohms. So what we want to do is draw out our series circuit, which looks like this. So we go out, go down, go over, create our first resistor, go over, make our second resistor, go over, go up, and go back over. So it says a 95 volt battery, so we'll write 95 right here, and we'll write 5 ohms right here, and 12 ohms right here. So what we want to do is write 95. So in this chart right here, this is the first resistor, which is going to be 5 ohms, and the second resistor is going to be 12 ohms. And with the voltage in a series circuit, what we want to do is we want to add those together. Actually, no. Hold on here. Trying to think real quick. Alright, so I figured it out. You had to add the resistors together in a series circuit, which would be 5 plus 12 being 17. Make sure to write 95 if you have this chart in the volt section under the total voltage. In a series circuit, to remember whether the voltage or the current stays the same, in a series it has an I, so I is for current, series has current, that's all the same. Now, what I want you to do is I want you to pause the video real quick and find V and then P. What you want to do is you want to multiply I by R, which will give you V, and then you want to multiply I times V, I times V being the answer for P. So pause the video, and when you get those answers, continue and see if you get the same answer as me. Alright, so what I did was, but make sure you get the right answers as I did. So what I did was, I multiplied 12 by 6, and that got me 72 volts. And I did the same thing, but I did 5 times 6, and that got me 30 volts of power of the stuff needed to that will charge it. So next, what we did is we did P equals IV, and 6 times 30 got me 180 watts. For the second resistor, I did 6 times 72. That got me 432 watts. Let me just zoom it in here real quick. And for the total, I did 6 times 95, and that got me 570 volts. So I'm going to end the video here. If you have any questions or comments, post them in the comment section below. I will read them, and I'll do my best to get back to you in any way. I will be creating another video that will have the parallel and combination circuits. Watch for those videos when they come up. If you like this video, press a like and subscribe to my channel for more informational videos on math, science, and any other interesting subjects. Anyway, I'm signing off. Have a great day.